Why, hello. How are you in this absolutely amazing day? I hope you're having a really good day. If you're not, I hope it gets better. Folks, this is some fractions review. We're talking about comparing fractions, and we're going to kind of go over a lot of things we've been talking about lately. I'm going to start this video off in an unusual way. You're going to need your notebook or something to write on. I'm going to start, usually I end my videos with telling you, now you do this, but I'm actually going to start this way. I'm going to start with a challenge. It may not be a challenge, it depends on how you are feeling about this. I'd like you to start by drawing a basic fraction number line, just like this, with 0 on one end and 1 on the other, and this little line in the middle, and I think you know what that line's supposed to be. So take a moment and do that, okay? You can pause the video if you wish as you do it. And then I'm going to challenge you to place the following fractions on this number line, okay? Whoa! Okay, take it easy, Mr. Ra. And so here are the fractions, boop, in no particular order. So I want you to pause the video. These are obviously not in order. And I want you to place a dot somewhere on this number line where you think these 5 fractions live, and then label them. Ready? Go ahead, pause the video. Welcome back. Okay, so what you're going to do is, as the video goes on, I might reveal the answers of what these are, so keep these right here. We'll get back to that. And let's get crack-a-lackin', shall we? So this one is going to be for a little bit later here. And now I'm going to have you draw a new number line. Now remember that all fractions, all regular fractions, live between 0 and 1, all regular traditional fractions. And what we've been practicing a lot is figuring out whether fractions live below 1/2, they are less than 1/2, or if they are greater than 1/2. So let's give a couple of easy kind of cheat sheet sort of ones that you can easily pick out. Just as soon as you see them, you can see what they are, okay? And the first one we're going to talk about is whole number one, whole number fractions, okay? Those are fractions like, for example, 4/4 is an example of this, or 5/5. We've already, see, I said 5/5 and then I did this. We already said what our first answer is for that activity at the beginning. 4/4 lives right here. So in your original number line, one of the ones I had was 4/4. It should live right there. And if you do not have it right there, please pause the video and move it. Okay. Whenever you have a number over itself, it equals 1 whole. And there's a lot of different forms that can take. Look at my messy 4/4. It can take 5/5. It can take 6/6. It can take 12/12. It doesn't really matter. Okay. What that means is that this number line can be divided up in lots of different ways. Right now, it's only divided into 2 equal spaces, but it could be divided into 4 or 12 or 16 or whatever. And if it's filled all the way up, well, that's the entire thing. And that's why these fractions, where the same numbers in the top and the bottom, equals 1. So if you see that in your travels, you automatically know, boy, that's worth 1. Okay, that's one of the ones that we've been practicing. The other ones we've been practicing are fractions that are equal to 1/2. For example, let's get back to our original example, our original challenge. 6/12. That lives right here. So if you did not have 6/12 right there, please erase it if you can and move it to the halfway position. How do we know that this 6/12 is equal to half? Because the bottom number is double the top, okay? If this was divided into 10 pieces, let's say, and 5 of them were filled up, that would be 5 out of 10, or halfway. If this was divided into, 18 pieces, and 9 of them were filled up, okay? That would be halfway, 9 out of 18. So whenever the bottom is double the top, and it can take a million different forms, they're all equal to 1/2. So that's something to watch out for, okay? Something else to watch out for is when a fraction only represents a little tiny part of the whole entire thing, WHOLE, a little tiny part. Let's imagine that this was divided up into, let's say, again, we'll go with 10 pieces or 12 pieces. It would really only live right around here at the very, very bottom if one out of those 9 or 10 were filled in, right? We can see if this was divided all the way across, 1 out of 10 would only get you that far. And these numbers are pretty far apart from each other. So 1 out of 10 or 1 out of 9 or 1 out of 7, it's a pretty small amount. If we go back to our original challenge, 1/9, so let's see, we've already used this one, we've already used that one, and then 1/9 would be right down towards the 0. If you do not have it here, move it, right? It's not very much. Imagine this was divided into 9 pieces. 1 out of 9 is not very much. So if you see something and the two numbers are far apart from each other, you know it's a pretty small amount, as opposed to all of them being filled in, right? It's right towards the other end. Another one is sort of the opposite of that idea, okay? If you have something, if this is divided into 12 pieces and 11 out of the 12, let's say, was filled in, well, that's almost the whole thing, because 12 twelfths is 1. It's only one more bit would be shaded. Only one more bit to be shaded, and it will be the whole entire thing, 1. So 11 twelfths, notice how close together these numbers are, 11 and a 12, right? If we go back to our original example, 9/10 was one of them that I gave you. That would also live really close to the 1, okay? If you don't have it here, move it. So 9, and man, I can't say this is exactly where it would live, but it lived pretty darn close to around here, okay? And we're done with that one. So you can see, as I stated before, that if the numbers are really close together, right? Another example of that would be like whatever, 7/8 would almost be 1, right? 9/10, so we already said that one. Let's say, I don't know, even if it's not just 1 away, I mean, even like, 7/9 would still be pretty darn close to 1. Does that make sense? They don't have to be only 1 away from each other. They could be a couple away from each other, but as long as they're close, then that, and it's not a 100% rule. It doesn't always work, yada, yada, yada. You know that, okay? The next thing I want to talk about is our good friends, the benchmark fractions. Now, you actually already have these in your notes. You can take them again if you want to. If you can't find where are those benchmark fraction notes, then you can not take this part. But if you don't have them, it doesn't hurt to take them again. Benchmark fractions are what I call the celebrity fractions. They're the measuring cup fractions. They're the ones we talk about all the time. They're the famous ones. 1/2 is a superstar. People in real life talk about 1/2 all the time, okay? And there's 4 others. 1/4, 3/4, and what are the last 2? You guessed it, 1/3, 2/3. Again, as I've said to you many, many times, if you need to do it right now, pause the video, take a minute, and memorize this list. In order. What lives between these two? Oh, that does. What lives between the, oh, to that one. Which one is closest to the 0? Oh, that one. Which one is closest to 1? That one. Take a minute. All right, memorize this stuff because it really comes up over and over and over again. Okay, and when we finally go back to our original problem, 1/3, I'll say it lives around here. So that's the final answer key for what you were doing. Now, what all of this is leading towards, of course, is comparing fractions, right? Now, if you're comparing fractions and the bottom numbers are the same, it's no big deal, right? If it's like 5/8 and 3/8, we're talking apples and apples here, people. Obviously, you would just compare the top numbers. 5 is greater than 3. If it's not that, use all the other tricks at your disposal, okay? Fractions that are equal to 1, fractions that are equal to 1/2, fractions that are close to 0, fractions that are close to 1, benchmark. Use all those tricks, okay, at your disposal, okay? There's also the other little trick. You see how this is equal to 1/2? Well, if you've got one that's kind of close to that, you can be like, oh, I know that it's close to 1/2, but it's just a little bit less. This is a little bit more of a complicated trick, but you can actually, I'd like you to think along those lines. Here's another example. 6/10. Well, we know that 5/10 is equal to 1/2 because the bottom is double the top. 6/10 is a little bit more than that. So that's a trick you can use as well. Check this out, folks. Now, here's the last but smurfingly not least, all right, is when we have two fractions that we want to compare. Let's say it's 4/5 and 7/10. And yes, I want you to write this down. Oranges, peaches. It's not going to work. We can't compare these two things if they're not the same. So what do? We either make them both 5s or both 10s. What makes more sense to you? Yeah, you can't, thank you for honking the horn at me. So yeah, it's easier to turn the 5 into a 10 than the other way around, because I'm not going to get into the whole division complication, but trust me when I say it's much easier to use this. So what do we multiply 5 by to get the 10? Well, we multiply it by 2. Whatever you do to the bottom, you do to the top. So now we're making an equivalent fraction. This fraction and this fraction are not the same fraction, but they're worth the same. So with your finger, you say, oh, now we're comparing tenths to tenths. Peaches to peaches. 8 is more than 7. Therefore, 4/5 is greater than 7/10. And we've shown why. I'm going to end this by giving about 3 more of these that I want you to do personally. 2/3 and 9/15. I'd like you to do that one by yourself. I would like you to do 3/4 and let's say 7/12. I'd like you to do that. And last but smurfingly not least, 5/7 and 9/14. This one. Figure out which one you need to change. Figure out what the multiplication is. Figure out what the symbol's in. I'm assuming that you still remember that that's greater than, that's less than, and that's equal to, right? Greater than, less than, equal to. I'd like you to do those, and then I will see you soon. And you can show me, or we could just talk about it. That's fine too. Hey, folks, have an absolutely fantastic day, and I'll see you in a second. Bye-bye.